Hey guys, so I'm going to give you a walkthrough of how to do a chi-square and a linkage problem. So this is from the homework. This is a walkthrough of one of the homework problems. So I'm going to turn off my video and I'm going to share my screen with you guys. And so this is the chi-square practice number 1 from your homework. And hopefully this will be helpful for figuring out if two genes are linked or not. So if they give you, first of all, I can already tell they're linked. Let's start with that. In a cross, a dihybrid test cross, that means they're crossing a heterozygous with a homozygous recessive. The expected outcome, you can actually just memorize, is going to be 1/4 of each possibility, which is what I have here as my expected. Out of 452, if I do 1/4 times my total of 452, I'm going to get 113. So I'm going to expect 113 of each. Now, let me just take a real quick step back. If you're like, but how do you know it's 1/4? We can actually do this cross. So if I cross my T's, we can do this with a Punnett Square and the product rule. My chance, this case, tall is dominant to short and purple is dominant to white, right? So our chance of tall is 1/2 and our chance of short is also 1/2. And again, how do I know they're what they're crossing? They told you. This is it's called the Dihyber test cross, but basically they're crossing a heterozygous with a recessive. So I expect half tall, half short. And if I cross my P's, I'm going to get the same thing. I'm going to expect half purple, right, and half white. So the chances of tall and purple would be 1/2 times 1/2, which is going to be 1/4. And you'd see that the chance of each of these outcomes is going to be the same. It's going to be 1/4. So to get my expected, we use our Punnett square. And in this particular case, since we expect 1/4 of everything, I can just basically do this one time, 1/4 times 452, and I get 113. And I know that it's going to be 113 for each of these since I expect there to be 1/4 of each outcome. Okay, so that's how I'm getting my expected. Now, to save a little bit of time, to calculate our chi-square, this is just a matter of plugging into your calculator. Remember, you'd always have this formula available to you on the formula sheet. It's observed minus expected squared over expected. So that's our formula for chi-square. And so I'm just going to go ahead and fill these in and save a little bit of time. So for this first one, I get 70, 39.73, 35.12, and 76.54. And when I add all of that up, I get 221.39. So my critical value is 7.82. My degrees of freedom is 3. I'm not going to go through how to find that, but this clearly does not pass. So this fails the chi-square test. All right. So what does that imply? Well, that implies that these genes, particularly in this case, that these genes are linked. How do I know that? Because I expected about 1/4 of each, but what you're going to see when the genes are linked is that most of them come out looking like the parents, and those are called parentals. So when it asks which offspring are the parentals, it's the tall purple and the short white. How do I know that? Because the definition of parental is an offspring that has the same combination as one of the parents. So what were my parents? Tall and purple and short and white. That's what I crossed. A heterozygous, which would have been tall purple, with a recessive, which would have been short white. So the offspring that look like one of those parents, those are my parentals. The ones that have the opposite combination, in other words, they got tall from one parent, but then white from the other, or they got short and purple, those are called recombinants because they have a new combination of the two traits. So the offspring in this case that are my recombinants are going to be my short white, my short purple, sorry about that, and my tall white, because these have the opposite combination. Now, the next thing they want is what are the percents of parentals and recombinants. Now the formula for this, super easy. Once you know which ones are your parentals, you're gonna add up your parentals over the total offspring times 100. So our formula is gonna be, so in this case, our parentals were 202 and 180. Sorry, over my total offspring was 452, and then times 100. That's going to give me my percentage of parental. So, and if I work that out, just to save a little time, I'm just going to make this really tiny. I get 84.5% parentals. And then my recombinants, so that's going to add, we're going to add up all of our recombinants. So it's going to be 50 plus 20 over my total offspring of 452 times 100, and that's going to give me 15.5%. And if you double check those, they should add up to 100%. So this is my percentage of parentals, my percentage of recombinants. And again, to get that, I just add up all my parentals over the total offspring times 100, and then all my recombinants over the total offspring times 100. What is the expected in a dihyber test cross if the chromosomes, if the traits are on different chromosomes? You would expect 1/4 of each combination. That's what you should get if they're on different chromosomes. That means independent assortment is happening, that it's random which gene is ending up with which other gene. If they're linked, I expect mostly parentals and a low chance of recombinants. Why do I expect to get any recombinants at all? Because of crossing over. That's why I do expect to get some recombinants. In other words, even if the genes are, if we scroll all the way down here, even if the genes are on the same chromosome, big B and big R, and little b and little r, it's still possible you could get big B with little r if crossing over happens during meiosis. And if these switch places, then it would be possible now for this parent to give big B with little r or little b with big R because of crossing over. So that's why we do get some recombinants, but what we see is a very small number in comparison to our parentals. All right, and then how many map units are part of the genes? This is actually really easy. The map units it's equal to the recombinant frequency. So in other words, 15.5. The unit for this is centimorgans. They made this unit up after Morgan that studied the fruit flies. So whatever you get for your percent, that's the same as your map units. And that's how far apart the genes are on the chromosome. So hopefully that's a kind of helpful walkthrough of how to do a chi-square for a dihybrid test cross and what the expected outcome should be, and you're going to know if the genes are linked, meaning they're on the same chromosome, versus if they are unlinked on two separate chromosomes.